Most of us have seen how the water of a swimming pool is checked for chlorine. The water is mixed with a chemical, producing a yellow color, the intensity of which is proportional to the chlorine concentration in the water. A colorimeter is an instrument that does this kind of analysis more accurately. The substance that is to be analyzed, or a compound created from it in a chemical reaction, absorbs light at a unique wavelength proportional to its concentration. Inside the colorimeter, a light source is directed at a diffraction grating that resolves the light into its constituent wavelengths. By turning a dial, one is able to select a narrow range of wavelengths to shine through the sample. That typically is the complement of the color of the sample. In this way, the maximum amount of light will be absorbed. Turning the dial rotates a cam that causes an arm to twist the position of the grating. This allows a narrow range of wavelengths of light to pass through a slit and into the sample. Some or all of this light is absorbed, and the rest is transmitted to a light-measuring photoelectric tube that causes a response in a meter. To run an analysis, we turn on the instrument to allow it to warm up for at least 15 minutes. Next, we use the top knob to select the proper wavelength of maximum absorbance. A set of standard solutions of several different known concentrations is prepared. One test tube that we'll call the cuvette is used for all measurement. This will minimize errors due to differences in the glass between different test tubes. First, the blank, or control, that contains all chemicals except the light-absorbing species, is poured into the cuvette, which is then inserted into the sample holder of the instrument. Note that the test tube's label is oriented to the front of the sample holder. We turn the 100% adjust dial so that the needle is set on 0 absorbance, or 100% transmittance. Now we remove the cuvette from the instrument and close the top flap, and use the dual-purpose on-off knob to select 0 transmittance, or infinite absorbance. We repeat this process until the meter does not drift. We get 100% transmittance with the control cuvette inserted, and 0% transmittance with no cuvette in the instrument. We then pour the control solution back into its own test tube, rinse out the cuvette, and add the lightest colored sample to the cuvette after rinsing the cuvette with a small amount of this sample. We insert the cuvette into the instrument, always with the test tube's label pointed toward the front of the sample holder, close the top flap and record both the transmittance and the absorbance. We pour the sample back into its test tube and rinse out the cuvette with distilled water. We now rinse the cuvette with a small amount of the next darker sample, then fill the cuvette with it and determine its transmittance and absorbance. After this second reading, it is wise to use the control solution again to recheck that the instrument still reads 100% transmittance with the control solution in place and 0% transmittance with the sample holder empty. Continue taking readings of all of the solutions of known concentration, then run your unknowns. Do all of these readings at the same time using the same colorimeter, periodically checking the instrument with the control solution. After you have collected all of your data, you can transfer the information to a spreadsheet program to graph the absorbance on the y-axis versus the concentration of the species being analyzed on the x-axis. Instrumental methods are profoundly important in chemistry, and we hope that you find that your experiences with colorimetry will serve as an interesting introduction to this type of analysis.